This chapter is about pair of linear equations in two variables. It teaches us how to solve real-world problems that can be represented by two linear equations with two unknown variables like x and y. This chapter primarily covers two main methods to find the solutions: graphical method, algebraic method. The graphical method, and this method will represent the two equations as two straight lines on a single graph. The relationship between these lines tells us about the nature of solution. There are three possible outcomes. When the lines intersect at a single point, the pair of equations has a unique solution. The pair is called consistent. For example, the lines for x minus 2y is equal to 0 and 3x plus 4y minus 20 is equal to 0 will intersect at one point, which is the only solution. When the lines are parallel to each other, the pair of equations has no solution. The pair is called inconsistent. For example, the lines for x plus 2y minus 4 is equal to 0 and 2x plus 4y minus 12 is equal to 0 will be parallel and will never meet. When the lines are coincident, one on top of the other, the pair of equations has infinitely many solutions, as every point on the line is a solution. The pair is called dependent and consistent. For example, the lines for 2x plus 3y minus 9 is equal to 0 and 4x plus 6y minus 18 is equal to 0 are the same. So they have infinite solutions. A quick way to check these conditions without drawing a graph is by comparing the coefficients of the equations. a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0. First condition, if a1 upon a2 is not equal to b1 upon b2, the lines will intersect, one solution. Second, if a1 upon a2 is equal to b1 upon b2 is equal to c1 upon c2, the lines will be coincident, infinite solutions. Third, if a1 upon a2 is equal to b1 upon b2 is not equal to c1 upon c2, the lines will be parallel, no solution. The algebraic method. These methods are used to find exact solutions when the graphical method is inconvenient. For example, when the coordinates of the solution are not integers. The first one is the substitution method and the second one is the elimination method. Now the substitution method, in this method we solve one equation for one variable in terms of the other and then substitute that expression into the second equation. This gives us a single equation with only one variable, which is easy to solve. The steps: from either equation, find the value of one variable, for example x, in terms of the other variable, for example y. Substitute this expression into the other equation, solve the resulting single variable equation, substitute the value you found back into the expression from step 1 to get the value of the second variable. The elimination method. This method aims to eliminate one of the variables by making their coefficients equal in both equations. The steps: multiply both equations by a suitable non-zero constant to make the coefficients of one variable, either x or y, numerically equal. Add or subtract one equation from the other to eliminate that variable. Solve the resulting single variable equation. Substitute this value back into one of the original equations to find the value of the second variable.